All right. Welcome everyone to the Software Craftspeople India community. We are a not-for-profit organization. Our goal is to connect people with the software craftsmanship mindset and grow a community of like-minded craftspeople. We organize talks, roundtables, workshops to help the community get better at their craft. We are committed to spreading new ideas by inviting thought leaders at our community. Well, we are Incubite, the founder and sponsor of the community. Needless to say, we are passionate about delivering value to our customers using craft to build high quality software. Let me introduce you the speaker for today. Today we have Mufrid Prilich with us, who will be talking about data ownership in legacy systems, building a foundation for data mesh. He has 20 plus years of experience as a software architect, developer, uh, give me a moment. Yeah. He has 20 plus years of experience as a software architect, developer, and a technical coach. He has worked in healthcare, insurance, and telecom industries. He has been deeply involved in developing enterprise solutions in complicated domains. On top of that, he's a domain-driven design coach and a frequent conference speaker. We are glad to have you here with us, Mufrid, and the virtual stage is all yours.
Thank you. Thank you very much for that nice introduction. So let me share my screen. Are we okay?
Yeah.
It's screen? Great. So I dropped off for a moment regarding any questions. I'm not sure if you mentioned it, but you can use the chat in Teams. I'll go through my presentation and then we'll try to answer any questions you might have, comments whatsoever afterwards, one by one. So please do engage in any way at any point, and we'll get back to it. Okay, so the talk of today, it's about data ownership and how that might help building a foundation for the data mesh. Narendra already introduced myself, so I won't talk too much. Sometimes along in past few years, somebody tagged me as domain-driven design enthusiast, so that was kind of nice tag to have, so I'll put it here. And I work in a small consultancy called Cowork here in Norway. Very much about strategic leadership and also technology leadership, where I put my work around domain-driven design. But there is this concept called tailor-made, which you might want to check out. It's getting a lot of traction in Norway and in other countries. So regarding how to do agile leadership in practice. So what's interesting about Cowork, another thing is this book called Reinventing Organization by Frederic Laloux. I'll be recommending a couple of books during my talk, which you might consider picking up and reading if you want. This is about how to organize your organizations somewhat differently. We are so-called leaderless organizations, so is it possible to organize the work differently? Well, according to Frederic Laloux, yes, it is. So I might encourage you to have a look at, really change the way I look at the work itself. This book this illustrated edition is rather short, is rather very easy reading. So, okay, so let's jump into the topic of today, and we'll start with the takeaways. What you want to bring take away with you. So we'll talk a little bit about these different perspectives between application development and data analysis, and this is kind of the very problem we are trying to solve, which I will try to formulate. And we will once we talk about data analysis, why is that important? We are getting very close to the needs, the business needs and business insights, and I will show you rather concretely how to understand the business needs with this specific methodology called domain storytelling. And we'll have a look at the data ownership and how it plays with domain-driven design in order to reduce this gap between application development and data analysis. Okay, so let's start with the first item. There is this inherent difference between application development and data analysis. Why is this so? And how do we deal with it? Well, let's start first with the problem we are trying to solve. Now, everybody wants to be data-driven today. That's kind of mandatory. If you're not exploiting your data, if you're not utilizing it, if you're not using it to drive decisions in the business, you're lagging behind. So everybody needs to be data driven. And in today's world, we have plenty of data sources there, and not only data, amount of data, but data sources are increasingly present, which means that we have to deal with data management at scale now more than ever. And scaling is something that brings complexity with it. And complexity brings social technical implications. So we'll dive into these areas a little bit more. So once you combine scaling with once you are in the position where you see you are scaling, your organization is scaling, your data sources are scaling, that brings complexity, and complexity is accompanied with social technical implications. So this is the problem we are trying to solve: how to be data driven at scale. Okay, so data is produced by the applications we are building. We are developing software in many ways, for whatever reason, aligning with the business, and those applications we are building are producing data. However, the applications we are building might not be very interested in looking at the data the same way as a business stakeholder might want. So this is because there are different types of data we are talking about. We are talking about operational data and analytical data. So when we are developing applications like your web application or enterprise desktop application in any domain, we are producing operational data which is transaction based and state aware, meaning that applications are mostly concerned with updating, managing the current state of the operation. They are concerned what is the current state of the application. So that is what we call operational data. However, on the analytical side, we want to introduce this notion of time. We want to aggregate business events and look ahead or backwards in time for in future insight or retrospect. Meaning that state is less important. It's more like an aggregated state with respect to time. And this gives us a different perspectives by default. We want to combine this. So now we can go a step further and how we have traditionally dealt with this organization-wise. So we have commonly, we can find a team for data analysis reporting, which is separate from application development. Now, example, I worked in a company, we had 30, it was a mid-sized company with 30 product development teams, all developing different part of the enterprise application system we were working on. However, there was only one or two teams dealing with data analysis and reporting. And I see this picture many places, that there is this separate team for data engineers, data analysts, and which are providing data for reporting purposes for business stakeholder, which is separate from application development usually. And this is okay because it's based on the real needs. When we want to provide data insight for business stakeholders, the data model for operational data is usually not adequate. Also because the operational data is very much transactional, state aware, not what analytical needs are centered around. So we have this different perspective between two types of data, and we have organizational structure that also tailor us towards centralized data approach, or centralized organizational structure to provide data analysis through very few sources. Whilst the number of sources on the operational side could be we have many sources on the operational side. We have only perhaps one or two sources on the analytical side. So we have this gap and the different ways of dealing with operational analytical data. So a couple of years ago, Zhamak Degani introduced this concept of data mesh. Now, I heard that you have already been introduced. We had a talk about data mesh in this community some time ago, so I won't go too much into detail. I assume you're kind of familiar with it, or you can have a look at it. But I'll just cover what is essential for this talk as I see it. So data mesh was the concept of how to be data-driven at scale, which was the problem we are trying to solve. So Zhamak Degani wrote this wonderful book. I really recommend it, and really explains why we are doing this and how can we address this problem of scaling and being data-driven at the same time. And she mentions 4 principles. The data mesh is built around domain-oriented data ownership, data as a product, self-serve data platform, and federated computational governance. Now, for the purposes of this talk and this topic, the first principle is what we will be covering. So domain-oriented data ownership assumes established domain boundaries. So you might call it a prerequisite for data mesh. And what do you mean by domain-oriented? Well, we mean that data ownership is closely aligned with data source, and the data source are all those parts of the application or different application generating operational data. Those are the data sources. And we want data ownership for analytical side also to be closely aligned with the operational data sources. Not possible to get it use the same model. However, can we get them as closely aligned as possible? Which means once we align with multiple data sources, we need to accept the fact of multiple autonomous yet integrated models. So how to reduce this gap between analytical and operational side? Reducing the gap will address the complexity with social technical approach, because we have seen operational science several years ago that decentralization helps address scaling, that we have microservices, we have domain-driven design, bounded context, and everything. So can we do this on analytical side? So pushing the gap of the source of analytical data is close to operational, addresses complexity, and social technical, because different teams deal with different parts of the application or different applications, also aligns well with data ownership on the organizational level. So what I'll be talking about, can we take a different approach of modeling of application data so we can have a better foundation for doing analytical work? So when we talk about domain-oriented, it's the best approach I have seen or used is domain-driven design. So I'll shortly go through this principle of strategic domain-driven design. Again, I assume you're a little bit familiar with it, but this should be enough for the purposes of this talk. So domain-driven design was a concept introduced by Eric Evans in 2004 in this so-called Blue Book. And on the strategic level, where we want to, when we talk about domain-oriented and what data do different parts of the system own. So we have the principle of strategic domain design are core domain, distinguishing with the problem and solution space using linguistic boundaries. So let's just briefly look at each of it part. So the core domain is the thing that distinguishes you from the competitors. So your operational data sources, one of them or some of them should be in your core domain. So one of the data sources is the core source of your core business. So meaning that not every part system will be well designed. So you want to focus on the core and perhaps have customizable software or outsourcing for generic subdomains and supporting subdomains. And we also want to distinguish between problem space and solution space. And this is what I will be covering today. We will show how to do domain analysis, at the same time how to do domain modeling. So we do the domain analysis to discover how the business is working, and domain modeling, how can we model our applications to address business needs. It's hard to map this one-to-one. This is really hard, and you just have to accept it. So we work iteratively to get it as close as possible. And the boundaries in the system, according to domain design, are linguistic, meaning that the language of the business guides the boundaries of your system. And once you accept the boundaries are linguistic, then you use the same language within the boundary everywhere, but within the boundary. You will have different dialects in your system. That's fine, but within every dialect, every boundary, you use the same meaning, the same semantics, which gives us two pillars of DDD: is ubiquitous language and bounded context. So you establish boundaries in your application by using linguistic boundaries. And to achieve this, you need cross-functional collaboration with domain experts. You want to build the software in a way that domain experts would have built it themselves had they been software developers. You want to really understand the mental model on the domain experts. Okay, so this is about strategic domain-driven design. What is your core domain? What distinguishes you from your competitors? Approach differently problem and solution space, which I'll show an example of in a minute, and use linguistic boundaries, which we'll try to conclude. Okay, so this was a kind of a theory part of the talk. So let's try to be a more practical. Let's try to show some examples. So I'll guide you through the domain of healthcare and a specific part of the healthcare domain called group treatment or group therapy. And we'll go rather deeply into this, and we'll try to show how can we model this domain using data ownership as a foundation to reduce this gap between operational and analytical needs. So we'll do first the domain analysis, and then we do some domain modeling. Okay, so a little bit about domain. So group treatment is for patients with identical diagnosis. So sometimes they see, okay, if we do the treatment in groups, you can have the best effects. It's very much used in psychiatry and conversational therapy, but also on somatic part and the post-injury training sessions, etc. So instead of being one-on-one with your doctor, with your physician, sometimes you have a group of patients meeting with the physician and doing, for example, conversational therapy. Now there are two use cases mostly in group treatment. You have planning and check-in. let's set up a group, let's plan the appointments, who will be participating, and then let's actually conduct the appointments, who has shown up, who has what has happened, and so on. So I'll guide you through these using this technique. Now, in domain-driven design community, we love to do collaborative modeling. Collaboratively with domain experts, you get business people, you get developers, you get architects, designers, everybody involved. People with questions, people with answers. But it is a very easy way to show who you want in a collaborative modeling session. Well, people with questions and people with answers. And there are many ways to do collaborative modeling, so I'll show you how to do it with domain storytelling. This was a method developed in the University of Hamburg in Germany many years ago, but it has been popularized and made available to wider audience by Stefan Hofer and Henning Schwentner. And this is a great book, great reading, very accessible, and this method gives great results with relatively little effort. You don't have to learn much to be able to use it. So I recommend you take a look at it. It's available on many platforms. Okay, so how domain storytelling can be used to analyze the domain? Okay, so let's start with the group treatment planning process in somatic department. So there is this department that provides rehabilitation after lifestyle affected diagnosis, like diabetes, or so the diagnosis that actually require you to modify your lifestyle to a certain degree. And there is this rehabilitation center in one that provides group sessions to give you some good advice on that. So, okay, planning of the group in this rehabilitation center starts with medical secretary receiving referral regarding the patient. And we are in this collaborative modeling session, and at the very beginning, we are talking with domain experts. So we have a group of people in the session. We have domain experts, we have developers, we have some management, and we start to draw this process. So we ask domain storytelling goes like this: you ask the domain experts to tell you their story, and you record the story in a visual way, and then you repeat it so to get confirmation that you have really understood it. And now, once we start to draw it, medical secretary comments, well, my job title is actually training consultant, but you can use medical secretary, but just so you know what I'm really called. Okay, so you note this. Okay, you go on and you make a little note about this. All those nuances in the language which I talked about could be really important. So next step is to a medical secretary consults about a referral with supervising physician. And then again, we get a comment, well, I am supervising physician, but my real role is medical supervisor of the course. Okay, great, we note this, it could be important. So medical secretary or a training consultant informs the patient and the patient's general practitioner about the registration of the training course, sends a letter about appointments and course agenda, and creates empty group without patients and put it in a course calendar. And these are all different interesting things start to happen. This is paper-based. Okay, why? And this is a long-term planning, and there are all sorts of roles involved: clinical leadership, healthcare professional, different disciplines, and they decide on the course agenda. And they say we never cancel a course. Okay, that's interesting. And first, when they have agreed upon a long-term calendar, then medical secretary will add the group in the patient record system. So our software that we are modeling actually is rather peripheral to this business process. So this was the process of planning, group planning in this somatic department of rehabilitation. So how do they do check-in? So they have planned the group, patients have got the letters, and now they need to show at the appointment at the group session. Okay, So how do they check in? So they check in at the venue. Secretary will verify through a manually compiled list who have checked in, and then will record the patient visit in the patient record system, but only the day after the appointment, using the same list. So she will or he will record no-show patients who have actually participated, who was no-show, who have canceled prior to the appointment. Supervising physician will formally approve this, and the secretary will send the invoice to the patients. So that is the planning and the check-in process in this somatic department. So, which is really important in domain storytelling, or actually any collaborative modeling sessions, are um, uh, uh, um, mixing together the people from different backgrounds. So you get domain experts from different backgrounds to be in the same room because they work differently. And it's on two levels. It's good for them to understand. So it's good for us developers to understand the differences in the business, how the different domain experts, let's say, use our system or do the business process differently. And it's also good for the domain experts themselves to understand that they do some things differently. So in this case, we had people in the same room from this rehabilitation center, but we also included the people from psychiatric department in adult psychiatry, because we did some work up front. Also, who is using group therapy in this hospital was our question with our contact in the hospital. And they did some, okay, there's a rehabilitation center, this is psychiatry department and adult psychiatry and so on. Okay, so let's get all together if possible. So we were lucky to be able to have people both from psychiatry and somatic in the same room. So on the somatic side, how do they plan the group? Well, medical secretary will create a group for day one with location in patient record system. And immediately we see that in this case, in psychiatry, medical secretary is much more involved with the software at the first place. And then she will create a group for day two. So there is some kind of predictability here for this for the types of group sessions they are providing. They know that they will have one day with certain recurrence every second Monday, and they will have every second Thursday on with different schedule. And then, according to those different recurrences, they will add a list of patients in each group, and the patients will attend the whole day. So patients will meet both on Monday, every second Monday, every second Thursday, and then, according to this group recurrence, the secretary will create a schedule in the patient record system and will add healthcare professionals, psychologists or physiotherapist or nurse for psychiatry department to the group or on different time slots. So the patients attend the whole day while the healthcare professionals attend a different time slot. So here we have a slightly different planning process. So it's more predictable. We know what days ahead we are going to be involved, and so they set up the schedule rather early. Okay, so how do they do check-in? There was two use cases, right? Planning and check. How do they do check-in? Well, there is a waiting room. Psychiatrists and psychologists retrieve the patients with the waiting room, and we see here that medical secretary is less involved in the check-in. The healthcare professional is much more involved from the first step. And the psychiatrist will himself or herself register show-no-show cancellations of the appointment in the patient record system and document the patient visit. So we have a more active role on the clinical side, according comparing to the rehabilitation centers. So in the first case. And then the medical sector will complement the already the registration in the patient record system with, okay, what happened with the visits? There are visits without invoice, and add some other specialists that have been involved but have not been registered, and we'll send the invoice to the group patients. So, okay, so this is the use case explained using domain storytelling. So we did this was our half-day workshop with the domain experts. So and we mapped more stories than this one, but it gives you and there are lots more conversations going on to get to this final artifact, visual artifact, but it gives you kind of idea, hopefully, what we want to achieve, to have some visual documentation of the business process, visual understanding of the business process. Okay, so that was domain analysis. So to be domain, or to achieve this first principle of data mesh, of domain-oriented data ownership. So when we ask ourselves, what is domain-oriented? So we do a domain analysis to get to this part of being domain-oriented, in order to solve the problem of how to be more data-driven at scale. So to be more data-driven at scale, let's define domain-oriented data ownership. So how we do this? We do the domain analysis. This was an example of how to do domain analysis. Okay, so we go back after this splendid workshop. Our team goes back to the office, and okay, so what's the next step? Well, let's do some modeling. So there are many ways to do domain modeling. You can use any whiteboard sessions, what you want, and many approaches. You can even start coding right away, as long as you accept that code is something that might be thrown away, and let's do some quick experiments. So I'll show you how we did domain modeling here using data ownership as a guiding principle. So what I mean, and we are still on the application development side. We are still on the, so that's this kind of the focus on this talk is about how to model on the application development side to give you a better foundation for data analysis. So we are still on the application development side. So how do we do data modeling using domain data ownership? Well, when we talk about data ownership, we are talking about business term is defined a set of data properties. So we've seen a number of business terms here in this domain storytelling process. We saw a patient visit, we had a group appointment, we had a group, we had group schedule, and so on and so on. So there are many domain terms. So you have each term, you map it with a set of data properties. So I'll focus on this one particular term, business term, which was really central to our case, which was the group itself. What is the group in the group treatment? Okay, so the first approach to modeling was functional decomposition, and this is what I guess everyone at some point in their career has experienced. So we map the function that user needs to do to perform his or her job, and we map those functions, and then we model according to these functions. So we talked about subdomains. So we did a domain analysis, discover subdomains, and in functional decomposition, subdomains are functions. And this is a classical approach. This is almost everybody, many systems are built using functional decomposition. So what are the functions in our case? So let's look at, we need to plan a group, to set up a group, we need to register attendance, and we need to send an invoice for each appointment. Some of the functions, let's just, for the sake of the presentation. So we do a model of this, okay? We can have one group in our domain model that we want to code in our software afterwards, one group that can perform all these functions. Now, I could have more nuanced way. I could have one group per function. However, it usually does not turn like this, turn out like this. It's mostly that using functional decomposition, you have no incentive to split up. So you see that you can have one model to perform all these functions. So how can data ownership verify this model? Well, we have one group and we can have all to perform this function. So we need all this data. We need attributes of the group should contain specialists, patients, appointments, invoice-related attributes, and so on. And we know that also in specific for psychiatry, there's this in Norway there is this reference to paragraph law for compulsory interventions. I guess it's common in many countries. So to perform all these functions, so planning a group and appointments, conducting appointments, sending invoices, we need all these attributes. So this is what data ownership tells us about functional decomposition approach. So we could have split along the functions, but usually we don't, because functional decomposition leads us to this. You might have one model to serve all these different functions. Okay. However, being from the domain-driven design community, there are many advices of trying to find different models before you select one and go on with one. So we asked ourselves, are there different ways to approach this? Okay, role-based decomposition could be one. So we search for the roles involved in different parts of the business processes. So which roles perform different functions? Then we are approaching to what's called task-oriented model. So subdomain is not only a function; it's now a role-based function. Okay, so let's look at this. So which roles are involved in the business processes of the check-in or business process? So we have physician involved in planning, along with medical secretary, while medical secretary is mostly involved with registering attendance and sending an invoice. Which gives us now, okay, we see that different roles. So on the planning part, we have physician and medical secretary, while on the check-in part is mostly a medical secretary. So now we have incentive to create two different models. One model for group for planning, one model for group for check-in. Okay, how does this look like in data ownership space? Well, we see now we are able to split some of the attributes. Of course, in the real world, it never splits nicely. There's always something that you can't put wherever exactly where you want it. That's how it is. So, of course, I simplify things for the purposes of today's session, but it gives you a kind of idea that something can be independent of something else as long as you dig deep enough. So we see on the planning side that who is involved in the group are especially patient's appointment location, while on the check-in side, we are concerned who has participated, who was no-show, who has canceled, and how do we send an invoice based on what. We still have this reference to paragraph law for compulsory intervention psychiatry. We don't know where to put it, so we put it on the left side. Okay, can we go even further, perhaps? How about the notion of time? Can we model time explicitly? So can we find boundaries at the base of which roles perform different functions at different times? So now we are approaching towards a user context. So we are asking our users, what is the context in your mind, your mental model context? You are employing to perform a specific function. And context is very time sensitive. Okay, so let's see if we can use notion of time to find a different model. Okay, so we still have three functions. We have different roles involved in each function, but using time, we see that we first plan a group, then we register attendance, and then we send an invoice. There is this time delay between the three processes, three parts of the process, which gives us another incentive. So now we have incentive to split along the user context. Functional decomposition didn't give us any incentives. Role-based decomposition gave us incentive to split along the roles involved. Time and role-based decomposition gives us incentive to split along the time axis, respecting the roles involved. Okay, can we go even further? What data ownership tells us? Well, it gives even more nicely aligned properties distribution. So we still have this planning context. Who is involved in the planning, setting up the group? Who is involved in the check-in process? And what properties are involved in check-in process, of course, and what properties are involved in the billing context, because billing is the last step of the business process. So now we can have three models, three in our system, in our application, in our code, which are aligned along the user context at different points in time. And we still struggle with this reference to paragraph in law for compulsory interventions, and we put it on the left side because we don't know where to put it. Great. So still, are we aligned with the business? Are we aligned with the domain? The first principle, data mesh, domain-oriented decentralized data ownership and architecture. Well, especially when we talk about legacy systems, which are very much functional decomposition driven. We notice the more complex the legacy system and the longer the system is in production, the more likely the domain language will be affected by the language of the legacy system. Meaning that when we talk about with domain experts in our collaborative modeling session, we might not hear domain language. We might hear the language of the domain of the legacy system. So we need to dig deeper. And then we have something called pure domain storing, which is the same process of domain storytelling, which we have explained. However, we want to capture the very essence of the business process. So the questions you ask in the pure domain story, if you want to do pure domain storytelling, are more like, how would you do this without the software system? What are you really trying to achieve? So why are you doing this? You're trying to discover the needs behind what the domain experts are telling. So let's have a look at it. This is group planning in the somatic department. And this is group planning in psychiatric department. Not really the same process. And on top of it, when we went to the hospital, when you go, there is this sign greeting us, showing all the departments involved in the hospital in the, I guess, the western part of the Norway. And I stopped and I paused and looked at it and said, there is no group therapy here. Don't they do group therapy in the hospital? Of course they do, but that is not their main, that is not their core business. That is not their core domain. You go to hospital to get some help on some issue you're having, and those issues are clinically divided, but whether it's what we have, medical genetics, neurosurgery, rheumatology, radiology department. So those are the specialists involved in the hospital. That's their discipline. And as a part of those disciplines in the medical field, they do group therapy, but that's not predominant. Okay, so and this prompted us to see, can we decompose the system differently? How about business capabilities? So the capabilities that business offered its customers. So now we have been removed. Now we go further away from the functions. We leave the functions altogether. They are secondary. We want to focus on business capability as our subdomain. And there are many ways to model business capabilities. You can go really far if you want. And it has product architecture implications. I'll get back to it in a minute. But let's just split it very coarsely grained here. Psychiatry and somatic. So on psychiatry side, we have the same process and on the somatic side. However, splitting along the business capabilities, we see that we can use more nuanced language. So we are not talking about doctors and specialists. We can talk about specific psychologists, psychiatrists that actually, and on the clinical side, we can even use this role of a training facilitator or a supervisor of the training course. So the splitting along the business capabilities, it gives us possibility to use more nuanced language, which is more aligned with the business. And if we want, we can have different models for each side of the, for somatic and psychiatry. And if we want, we can go even further and split along those time and role-based decomposition. I'm not suggesting you do so every time. It might be costly, but just considering the business capabilities on the course level could give you some interesting gains. Okay, so what data ownership can gives us if we model it along the business capabilities? Well, we see that we can have more nuanced language on psychiatry and on the somatic side. So we can use a psychologist, psychiatrist properties, which are not relevant for somatic side. And we finally have a place to put the reference to a paragraph in law for compulsory interventions, which are only relevant for psychiatry, not for somatic side. And there are many business capabilities to find. Those department list is a great place to find it. So you have neurosurgery, birth clinic, cardiology. So if you want, you can go even further. And you find the business capability everywhere. You find them in other domains, for instance, in insurance. So what is insurance about? It's about selling products like house insurance, car insurance, life insurance, not about selling policies and coverage. Those are mere functions of the business capability. And I mentioned that these are product architecture ramifications here. Once you realize that business capabilities are something to be modeled around, then we ask some questions that we go to our product leadership. So, which users are we tailoring our products for? Are we tailoring towards psychologists, psychiatrists? Are we physicians on somatic? And how are we going to customize a one product for different business capabilities, or are we going to develop separate products? What are the trade-offs here? The cost of customization can be very high on complexity level. However, the cost of developing separate products could be very high initially. So you get this deep product architecture issues to answer. Okay, so that will lead some really interesting conversations in your organization once you get there. And so let's wrap up here. What I first would like you to consider is can you avoid functional decomposition? Perhaps not going all the way to business capabilities decomposition, but just try to do something else in functional decomposition, because you really don't understand user needs. Because you might understand them when you have conversation with domain experts or collaboration. But when you look at your software system like 2 years after, 5 years, or even 10, 15 years after, many legacy systems live for that long, right? You can't discover those user needs. They are hidden behind functions. The only thing you need functions. You don't see user needs at all. And you have no incentives to decompose, which leads you toward this canonical domain model, which leads to this gap between operational and analytical side. And this is one of the main reasons we exist. We develop applications using functional decomposition. We are drawn to this one domain, one data model, one domain model. And when we want to do business analysis, to be really data driven, now business does not operate along the functions. Business operate along the line business capabilities. So that's why consider modeling around business capabilities to unlock the real business needs. So functional decomposition will get you very far from the analytical needs. Business capabilities will lead you much closer. Of course, there is a cost here, but you can at least consider moving away from functional decomposition. And to get there, you use a language as a tool. The same domain term in different subdomains defined with different or possibly overlapping set of data properties. So you might also consider duplicating some data properties across different terms or parts of the domain model. And you want to use domain language, not the legacy system language, to discover this. This is where domain-driven design shown. So this is it. You need to respect different needs for application development, data analysis, but you want to align it. That's what data mesh talking about. Let's align data ownership with the domain boundaries. However, to discover domain boundaries, you use domain analysis methodologies such as domain storytelling. There are others, like event storming is also popular. But you want to get closer to the real business needs. And once you do analysis and modeling with data ownership, you will get near functional decomposition and see if you can try to avoid. But data ownership works, domain-driven design approach using language as a tool, as a main tool, is much more capable, or is more, but very much capable of giving you business aligned data ownership. We saw this. We saw that this nuanced language of when we talked about psychiatry versus somatic was driven by our drive to discover the real domain language. So this is it. Different perspectives. Data mesh helps approach it. Different approach to modeling. We talked about, and data ownership as a guiding principle. So that's it. We have some minutes for some minutes left for any comments or questions. Or I hope you enjoyed it. Thank you. Anyway.
That was amazing. I hope you're seeing all the reactions we are getting from the folks. I think there's a question by Josefa. Yeah, Josefa, go ahead.
Yeah, hi. I just wanted to ask, practically, not always you're going to work on projects that have very well-defined scope, that this particular project is going to do XYZ thing, and that's pretty much it, and it's going to be limited to this much. So oftentimes it is gradually and iteratively more functionality gets added. And while working on such projects, we often do not have the whole picture the way we had while we were going through that example. This is the department. Oftentimes, I might not even know that in future I'm going to even add some functionality that the psychiatric department is going to need. I might not know today. I might only know that I'm just going to work in some XYZ department. So how do you plan for that? because this looks like there's a lot of upfront planning and thought process required to get to the level of design that we talked about right now.
Yeah, a great question. Which reminds me that I need to stress more a need for doing this iteratively. So these are real problems you describe. They're very pragmatic problems. So I relate to that. First of all, the domain analysis approach from domain-driven design are not time intensive. They are very intensive in the short span of time. Like I said, half a day we did, and we really understood the model. So I'm not advocating for a long upfront analysis and planning work. Meaning that you can do them often, right? You do the one session here, understand a little bit of it, and then you go and work on the code or understanding the business, and then you go back and do another session, which is quite effective. However, predicting the future needs of the business, it's really difficult, which means that you need to do iterative approach is very mandatory here, and it requires, but regardless of what way you use the model, the systems, it requires the ability to refactor your model, to remodel at some point stage. And there are different ways to do this. One of them is to, if you have, it's always easy, as I see it, it's always easier to put things together, to compose than decompose in the software, right? Like you want to pull things apart, you have all those dependencies going on and coupling, and you struggle with pull things apart. Composing two different things that do not have much dependencies on each other is easier. If you start with some level of decomposition away from this one model, it gives you more options on how to put things together once you discover the future needs, because you cannot anticipate all. So starting with some level of decomposition, some level of multiple models gives you more options, but you need this ability to refactor, which is not always easy, especially in legacy environments. So the combination of refactoring ability and your foundation of model that have multiple models gives you some optionality. Yes, I hope that's okay.
Yeah, that answers. Thank you.
I see some things in the chat. Shall I just go through them?
Yeah.
Okay. When working a legacy system with existing complicated data dependencies, brownfield event. How do you personally strategize? Where do you start and tackle the problem? Well, this project actually was a brownfield. So there was a legacy system already involved doing much of the functions we have already covered. And so our task was replace the legacy system. That's kind of a common thing. And of course, then you need to attack the weak spots first. That's my approach. Okay, so what are the things that legacy systems or the systems already involved do not provide to the user? And then you try to build on top of it. So in domain-driven design, there's this great pattern called the anti-corruption layer, when you try to interface the existing functionality through some translation layer, API combined with some mapping, and then you develop the value-added model on top of it. It's okay in many cases However, technology can give you some challenges. Here, I was involved. This was Borland Delphi from 1990s, if you remember those technology, our legacy system, and we wanted to do this on the .NET platform. So getting those two to integrate was not easy at all. But we did something like through sharing parts of the database, not everything, but just part of the database, and trying to integrate them, which was really useful. If you can integrate the new part of the model and the existing part of the model in the same user interface. So having this client-side user interface integration instead of backend integration was something that gave dividends to us. So, and you start working with it, and you start to provide value. And the thing is, you need to move quickly to understand where the business really is interesting is in this new stuff, and then you build on top of it. You don't. Trying to be as agile as possible, and you need, of course, time is as important. You cannot expect many quick wins. Some quick wins are there, but to really replace the legacy system to achieve something in brownfield that really gives value, it could take some time. So I know projects going on for many years. But in the end, if you're persistent, you'll get there. So don't give up. Yes, domains itself evolves very much. Very good point, and that's also meaning that one of the things that you can take from this talk is the multiple options. So this exercise of providing multiple options for yourself, for your team, and doing it iteratively, meaning that, okay, this model that we discarded 2 months ago could be the real model next year when the business evolves. So this exercise in modeling gives you options that you can revisit. Of course, it's always difficult with business changes, and you need to couple the refactoring, but some refactorings are really hard to do. You cannot expect to do them quickly. And what I've heard from those successful companies out there, the Netflixes and Netflixes of our world and Airbnbs of our world, that they have started with one system, one model, and they have realized conveniently at some point that need to rewrite the system. Now, you rewrite at a point when the cost of rewrite is still up for grabs. When you go like 20 years and you want to rewrite, then you're really stuck. Then it's really difficult. Now in this brownfield situation. But if you can realize once you've gone you get some traction in the market, okay, now I see the domain changes, the market changes, we need to react. We have the capability to rewrite. And it seems that they have rewritten their software several times. And so this ability not only to refactor, but to throw away the model and start over again. But you need to do it at a point in time where it's feasible, not wait too long. So that's one of the ways you can tackle the evolving of the domain itself. Okay, who should be the owner of some data points that are shared by, written by all subdomains? Can be some form of central coding that affects other business flows, subdomains, etc. audit flows. Yes, this is really a central point dilemma. I would, of course, challenge you. Are there some points that are really central to subdomains? And we see that so often they are, but they are more often than not as many as we might think. So there are very few. Now, I just was recently involved in a data mesh project in the energy company, and they try to find the central data point, which is common by all subdomains. They found one, which was definition of a country. This is a multi-international international company doing energy recovery in many countries. So for all domains they covered, there was one concept, country, which was common. So that was kind of interesting. That's okay. So even in a big enterprise, they struggle to find something that is really common for many things. So there might be, but and then of course that requires central coding, as you said, central ownership. But of course you need to be really careful about dependencies there. If you want, like if you have, I worked in a company 30 teams, we have the one common repository for some core structure. It was really hard to do any changes in the core part of the system because everybody was depending. Yes, next question. Can you please explain how data autonomy changes when data ownership is decomposed? Well, to me, if I understand the question correctly, they follow each other very well because you might look at this. In this example, we had so you have a hospital with all different departments, and you have psychiatry and you have somatics, and so allowing for data ownership on psychiatry side to be different from somatic side allowed for autonomy on the data team. So we could expand with more properties that are specific to the psychiatry, but do not affect the somatic at the same time. Meaning that the team and the software providing functions for psychiatry could evolve more autonomously and regarding that comparing to the somatic part. So this is, if I understand it correctly, so decomposing data ownership gives you more autonomy, which is one of the principles for data mesh as well. And you need to, if you go even further towards reporting and analysis, if you are content with the decomposition and autonomy you have established, the ownership you have established, you want to maintain that ownership and autonomy all the way to your data analysis platform as well. So you form what data mesh called data products that align with operational data, but they're not the same, but different one. And you want to keep that autonomy of a data product all the way to the data analysis platform. And there are many, of course, issues to discuss here, but that is kind of, if it's possible to keep that logical coherence all across different technological infrastructure platforms, that then you really achieve the autonomy. Yes.
Sounds good. I think that's all the questions, and I think we are almost kind of overshooted our
we have
decided upon time. So I think just to end, summarize and ending thoughts, the recording of today's session would be available on the YouTube channel shortly.
Great.
We also have our WhatsApp and Slack communities. The links will be posted in the chat shortly. Join us there to stay updated with the upcoming events. And our next event is going to be on the December 16th. We will have a fireside chat with Adam Thornhill. Adam is the founder of Code Scene platform. So really looking forward to that. And until next time, I think thanks a lot, Mufrik, for taking the time out and spending time with our community. Really, really appreciate you spending time with us.
Thank you all. It was really a pleasure. So thank you, and looking for. I'll share the slides with you so you can share with the people involved. So looking forward to the recording. So thank you all.